Okay, today is an exciting day and we've got most of the parts that we needed have arrived to assemble our spindle. Um, very excited. So we have some little baby end mills have arrived, and we have our DC motor driver, which is a lot chunkier than I thought it was going to be, which is probably a good thing. I like the nice big heat sinks on it, so hopefully that will do us a good job. It has a potentiometer on it, but it should be pretty easy. It comes with a nice JST connector here, so we can pop that out. And we should be able to connect that up to the PWM on the controller board to control spindle speed. That's pretty nice. And we have the spindle itself, the spindle motor itself, which comes with an ER11 collet already on it, which is a Genmitsu CNC motor, 24 volts, 20,000 RPM. So I'm going to be running it only at 12 volts. So obviously I'll lose some power, but we'll see how that goes. Might be okay. We'll see. The best way to know is to test it, and obviously that comes with the ER11 collet already attached to it, which is pretty nice. So next thing I have to do, I suppose the first thing I should really do with this is figure out exactly how it's going to mount onto here. So it's going to bolt onto this block with some, sort of mounting system. I reckon something that it'll sort of slot into like that, and then we'll also grab around the sides, and then that'll all bolt. That whole assembly will bolt onto there. And yeah, then I got to wire it up. So I need to find a space inside the electronics cabinet for the driver, run some wires, and then it's ready to go. We're ready to cut some stuff, which is, I keep saying, it's exciting and terrifying. I also got this stuff, which is some A4 size 6mm plywood. So that will be what I'm going to use to test. The first tests that I'm going to do are going to be done with that material. So nothing left to say, just gotta go and do it. So first thing I'm gonna do, I'm gonna design the bracket to be 3D printed to hold the motor. So that's what I'm gonna do next. Okay, the motor mount is finished, and it turned out pretty well. It was turned out to be a really nice print, and then about halfway through, my spool of filament ran out, so I had to hot swap it, which is what led to this little gumminess here on the side, which just kind of ruined the outside of the print. But unfortunately, that also bulged on the inside there as well, so it was a lovely fit for the motor. That part, that's a really nice slip fit, and then it gets a little crunchy, and then so I had to actually take the Dremel and sand down some of the inside of that with a little sanding drum. But it's fine fit now. It's pretty nice. Has the holes lined up for mounting the motor. I also printed this completely solid, so it's really, really tough. I also added this nice pattern which matches the vent pattern on the face of the motor, which is pretty nice. So yep, that all went together fine. Happy with that, and it fits just on here, bolts on nicely. So I'm going to assemble this, which should pretty much have the mechanical assembly then of this entire machine finished with this one part bolted on, with the motor bolted on. So I'm going to do that, and then I will move on to doing some wiring. So something you guys can't see underneath here is the two screws that go in here to mount the face of the motor onto the block. They are little M4 tapped threads into two holes in the casing of the motor on the face. The only thing with them is they're just tapped straight into the case, and they don't have any there's no like end stops. So when you are screwing your screw into when you're screwing up into this, you can screw straight through the casing and right up into the rotor, and you can actually lock the motor by putting a screw too far in there, and it will just jam against the windings and stop the motor from spinning, which is not ideal. I would like if there was a little, even, you could do it pretty easily, the sheet metal, just like a little hook bent into it that stopped the screw from going all the way through. But yeah, it's just a through hole, threaded through hole that goes straight into the body of the motor, so you can just put a screw straight through that, which is not ideal. But it just so happens that my clearances and the thicknesses of this and the length of these screws, it'll bind up nice and tight, and there's plenty of clearance. The motor will still spin without hitting those screws. But it's something that if you were designing, if it was some other orientation and you had something that, I don't know, kind of hard to say. You should just pick the correct length of screws so that it's not a problem. But yeah, I don't know, maybe if there was something could shift and the motor could push down onto the screws more than you had expected it to, they could pop up inside while it's spinning or something like that. Probably unlikely, but just feels like a little bit poor design to me. But then again, this is not exactly the most expensive spindle motor you could buy, so I don't know if I can expect too much from it. And there we have it. That's the spindle motor mounted with its ER11 collet and an end mill put in for good measure. So I think there's nothing left now but to turn it on. Oh, I really don't want to. I'm so scared of what this thing's going to do. But before I turn it on, I have to wire it. So I'm going to pop open the electronics cabinet, find a space for this, wire it up, redo this connector to accept PWM from the control board, run the motor wires, and then we're ready to at least turn it on with some power and, you know, spin the spindle up and make sure it doesn't, you know, shake itself to bits. And then the next scary part is to actually cut something. Okay, so I'm gonna go do that. Okay, wiring is mostly done and we're ready to go for the first power up test to see if this works. So the only thing that's not the final wiring here is I have just connected it to this potentiometer that it came with, so that I can just test it, just bring it up slowly to make sure nothing, you know, goes crazy or tries to kill me. I've also, for safety, taken the collet and the end mill out for this first test. So let's flick it on, see what happens. Nothing is happening, so I think that's a good sign. All right, let's twist the pot and see what happens. Hey, yeah, we have life. Okay, that's nice and slow. Dial it up. Amazing. Woohoo! That's max speed. That is awesome. Brilliant. So I've no idea what speed that actually is. I need to get. I don't have like a tachometer or anything like that, so I might see if I can get one of those to see what that spindle speed is actually coming out to. I'm technically under driving this motor, I guess. Hey, that's amazing. All right, well that's a success. No excessive vibration. All seems to be nice. No sparks, no smoke of death. So yeah, I think that's all great. Okay, so next thing I have to do, which would be the final bit of wiring, is I just need to make a new cable, which I can plug in there and will connect to the controller board so that the controller can control the spindle speed. Once that's done, you know what we're ready to do. Ready to set this up and start cutting. Well, actually, the first thing I'll do before that, I will wire it all up sensibly with the thing, and I'll make sure that I can really accurately control the spindle speed with the software. Make sure that I'm happy with how that all works, and then I will go off, do some design, and I'll cut something for the first time. So excited, can't wait. Not even scared anymore, now I'm just excited. So I was working on doing up the final wiring for this guy, basically to replace this little potentiometer, which was previously the input to the spindle speed controller, and just replace it with a piece of wire that would jump it, this one here, this connector that would jump it straight to a PWM output on the board to control the spindle speed. So I did this, and I'm going to show you now some strange behavior that it's exhibiting since I did that. I have fixed this, but it's just worth showing you. So basically what I'm going to do is I'm going to tell
the motor just to spin up to top speed. Okay. So that works pretty fine. As you'd expect, tell it to go top speed, motor starts spinning up to top speed. The problem came in when I was basically trying to tell the motor to go at much lower speeds. So, for example, here I'm going to tell the motor to go to about 50% of its top speed. So it's kind of spun up there, but you can hear it's sort of, it's kind of, the speed is changing, it's not moving smoothly at all. So if I tell it to go just a little less than its top speed, it's gotten even worse. It's really struggling there, which doesn't really make sense at all, because previously when I checked off this voltage using the potentiometer, it had no problem spinning at lower speeds. So I was trying to figure out exactly what's going on here, and in fact the problem is so bad that if I put it down to a very low speed, it just doesn't work at all. And I don't know if you can quite see it on camera, but there's a little LED that's here on the top where it says forward, and it's kind of just blinking, flashing really inconsistently, which is strange because I'm pretty certain it's not supposed to do that. So anyway, all of this got me thinking, what is the difference between this and the PWM output from the controller board? And the difference is that one is a smooth analog DC voltage, the other one is not, basically. So when you spin the potentiometer, you get a smooth analog sweep from 0 to 5 volts, as this one is calibrated for with the input voltage there. So that works great, and the DC motor controller likes that nice smooth DC input, and it's able to use its internal circuitry to then convert that into a 12 volt PWM signal. That's then what is driving this motor. So what I had to do was I had to try and figure out a way of making the PWM signal like a smooth DC voltage. So if you don't know PWM signals, essentially they form a square wave that turns on and off in a pattern that's called the duty ratio. So in fact, the reason why this would work at its maximum duty ratio is because essentially the maximum duty ratio for PWM is just like pretty much always on. So at that point, the DC motor controller was experiencing, what it thought was just a constant 5 volts, and it was pretty happy with that, and it would run. And then as you brought the duty ratio down, it would be accepting of some of those voltages, but it still didn't like the noise in the signal, and they would be a little choppy. And then, like you saw, at about half of that, it didn't really like it at all, and it was really inconsistent. I could run to about 70% of the motor's speed, and it would still run pretty smoothly. So what I did was, essentially, I had to go back and use some of my long forgotten knowledge from studying electronic engineering, and I designed a really simple RC filter circuit. So this is a low pass filter. It's designed to clip off all of the high frequencies and just leave you with, sort of DC. So this is just the components I happen to have on hand: 22 microfarad capacitor and a 2k resistor, and yeah, they kind of work. So I'm going to turn this off. Ooh. We're going to plug in the filter, and we're going to see what the effect is. Okay, we've got the filter connected. So that is running at the last speed that I set, which was quite a low speed, which was about a tenth of its top speed. So if I go, so I'll turn it off first. Oh, well, that's not great. Huh. Oh, okay. Alright, there's some connection. So yeah, this is breadboarded, so I think I had shorted out something there on the breadboard. Okay, let's try now. So let's see. Let's try run it at that same about 50% speed as we did the last time, and hopefully this time it's a good bit smoother. There we go. That is a hell of a lot better. It's far more consistent. And then I can also turn the speeds down. So let's go to about 25%. And that's far more consistent. That's way better. It previously wasn't able to really do that at all. So then if I turn it off, there we go. And you'll see that this direction LED is just barely lit, not flashing anymore, so indicating that we've got much more smooth signal stuff going on in here. So that's about it. I just wanted to show that strange behavior and what I did to solve it, because if you didn't really know what was going on here and you plugged it in, that's kind of a bit baffling, especially if you just use a multimeter to check your voltages. That the multimeter will give you the average voltage anyway. So unless you had an oscilloscope, you wouldn't see any difference in the signal really. I just happened to know that the PWM isn't going to be a smooth DC signal, and I was able to use some of my knowledge from knowing a little bit about electronics to figure that out and what I had to do to solve it. So yeah, as you saw there, wiggling some wires had an effect. So this is obviously just a setup I had to test it. So I'll put these components on a little board, solder it all up, and make some jumpers for it and everything, so that I have that nice and secure, good connections. Okay, so once that's done, I'm going to move on. I'm going to set up some testing to actually cut something. Okay, this is the moment we've all been waiting for. I'm going to press the button. I'm going to run the machine and see if it'll cut something. This is the very first try of this. I think I have everything set up right. So this is my workpiece. I'm gonna use this A4 piece of 6mm plywood. I have a design that I did up the tool paths for in FreeCAD. It took me a lot longer than I was expecting it to take. I also have a slight issue with the code that I managed to generate from it is something like 100,000 lines long, and the free version of Ultimate CNC that I have will only let me run 30,000 lines of that. So it'll start and it'll do at least some of the engraving, so I can see the shape that's going to turn out, see what it'll do, but I won't finish it, so I won't get the final shape with this cut. But I'm okay with that. I'm just really, all this is, I just want to see, will it cut, will it just crash, will it fall to bits? I have no idea what to expect now when I hit this button. So I think that's enough talking about it. I'm going to hit the button and see if this works. I might be back very soon talking to you, explaining that there's some problems and that I have to stop and start this again. But yeah, this is it. We're doing it live. So I'm going to hit the button now and pray. I think it's working. Oh my god, I think it's working. Making some gnarly noises. But I think it's working noises. Oh jeez. Okay, so there was a problem there. A screw seems to have shook itself loose. So yeah, I'm gonna fix that and come back. Okay, we're back. Basically what happened was these screws that mount the bearing carrier down to the bottom bracket there, I was messing around with them because of some alignment issues I was having with the screw. So they were, it just wasn't tightened up properly. So I've tightened that back up again, cinched everything up, make sure that my axes are all nicely aligned, and we're going to just kick off that same program again. I think I've got it zeroed at the same place it was last time, so hopefully it'll fall back into that groove that I had left. But alright, take two, let's try it again. Yep, another issue. I think this one might be something to do with what is happening. Ugh. Okay. Okay, here we go. Take three. Fingers crossed. I think that's supposed to have lifted up, but it's not. Why is it not lifting up? Okay, I forgot what take we're on. So let's just fingers crossed again. Okay, that's better. The dead axis is moving again. Let's see, can we cut without everything shaking to bits? Cutting air, that's good. Seems like we lined it up right. Close enough. Hey, it's cutting again. I really don't know what the noise is. I don't like it, but I have no idea what the feeds and speeds or anything are supposed to be on this either, so yeah. Could be anything. And there we have it. Yeah, it seems to work. this crazy contraption that I built. It definitely cuts anyway. So you see though, yeah, what I was talking about it didn't finish the pattern that you saw on your screen a little while ago. Kind of just engraved the outline of, and not even the full shape. This is meant to be a triangle, obviously it's meant to be a full circle. Didn't even get to finish the whole shape. So probably a few things going on there. Obviously the license for the software not allowing me to run the entire amount of G code that I had generated. Also, I don't know if I chose the wrong kind of tool path for this, maybe, so that it didn't work well. But I mean, I have officially built a CNC machine. All it can do so far is cut wood. I mean, maybe it can do other things, I have no idea. But it can definitely cut plywood, which is great. I never thought I'd get this far. I never didn't even think it would actually end up cutting stuff. I thought maybe I could do like some really fine little surface engraving on things with it, but seems I can cut stuff. So I'm beyond happy with this. Can't believe it. And fortunately for you folks, or maybe fortunately, this is the end of the series. I'm going to leave it here. I mean, the machine is far from finished. There's tons more I could do with it, and I plan to do more with it. I plan to use it as a tool and expand on it, and do other things. Dust collection is apparent to be an issue with these machines, so I need to get on that. I don't even own a shop vac, so I'm gonna have to figure that out. I need to make some sort of cover for it, because now that it's a working machine, it's gonna live out here in the workshop where it does get a little bit cold and a little bit damp. But yeah, that's it for this video series. I hope you've enjoyed this journey that you've been on for the last few months. You've shared with me, and if you'd like to help support me do this in the future, best way you can do that, you can subscribe to the channel, you can share it, you can like the video, share it all with your friends. And if you want to help fund my future projects, make them bigger and better, you can find a link in the description to my Patreon. All the money that comes in there will go straight back into making these projects bigger and better in the future. So yeah, that's the end of this journey, and thanks for watching, guys.